All right, everyone. I'm going to get started because I know we only have an hour with you guys today. I just want to thank you guys for inviting ThyssenKrupp here to talk about some elevator education. We're going to talk about Elevator 201, which is focusing on mid-rise buildings. My name is Carly Raven. This is Steve Mulligan. We both work for ThyssenKrupp, like I mentioned, in our new construction side of the business. So anytime you guys are designing a new building or writing specifications for elevators, escalators, power walks, Division 14 specifically, you can reach out to either one of us. We cover DC, Maryland, and Northern Virginia. I know I see you guys on a lot of our projects that we look at, so you're definitely a big firm here, and appreciate you guys having us out today. There is a sign-in sheet coming around, or maybe back there floating around. There's probably a couple sheets because there's a lot of you. If you want to sign in for me to get credit, if you are an AIA member, you will get one continuing education credit for this class. So I'm going to go ahead and get started. And I think I'm allowed to turn this off now. Maybe? No? All right. Okay, so mid-rise buildings. Typically, I know you guys probably design a lot of different types of buildings, but if you just want to shout out kind of what's your primary focus here. A little bit of everything.
Mid-rise, high-rise.
Mid-rise, high-rise, okay. So basically what we're looking at is what AIA is defining as mid-rise buildings here is residential, hospital, hotel. You have office buildings also. So for this presentation, focusing on mid-rise applications, we're really going to talk about traction, machine roomless elevators, and kind of your traditional machine room elevator style. A little review. I don't know if we've been here previously to give you guys the Elevator Education 101, which is focused on low-rise applications, but really we're just going to talk about kind of a little review here of what makes up vertical transportation. So what are the different components that you guys can specify for Division 14? So you have hydraulic elevators, you have your traction elevators, there are 2 elevators in one hoistway, freight elevators, multi-directional elevator, and you have power walks, there's escalators, stair lifts, and then high-speed power walks also. I'm going to move this so you guys can kind of see. Okay. No, it's not working. Did I do something? No. There's all this stuff working. Oh, there we go. Okay. So traction elevators for mid-rise buildings. Why do we want to use traction elevators for mid-rise? So what we would have talked about in Elevator Education 101 is hydraulic elevators. We use those primarily for low-rise applications because of the they have slower speeds than traction elevators, and they're typically used for low-rise because of the limitation they have on travel height. So hydraulic elevators can typically get to about 60 feet of travel, and then you're kind of maxed out with that option. So you would have to go over to a traction elevator at that point. And for mid-rise applications, we're talking about really anything over 75 feet of travel. It's considered mid-rise or high-rise even.
Yeah, IBC defines high-rise, yeah, anything over 75 feet above the lowest level for fire access.
Correct. So traction elevators will give you a faster speed than hydraulic elevators. They also can have your travel height can exceed with traction elevators also. So for mid-rise applications, this is really what you want to use when designing your building. There's 2 different types. There's the machine roomless traction elevators, which you probably use most often here in this market. In DC, with the building height restrictions, you're really primarily using machine roomless traction elevators. If you're going out a little bit further into Virginia or Maryland, or if you have jobs all over the country and other places where there's high-rise applications, you may still go with a traditional traction elevator where you have your penthouse room above your hoistway with the machine sitting in your penthouse. The machine roomless option is where your machine's at the top of your hoistway, and it can be either mounted above the elevator cab or it could be on the side on the car guide rail. So it just depends on the elevator manufacturer that you choose. So we're going to go over some basic components of the traction elevator. So the gearless machine is going to be, this one we're looking at here is a traditional traction elevator. You can see that the machine's not in the hoistway, it's on top there sitting in a penthouse. That's basically above the hoistway. All elevators have a controller, a control system. This one here is shown again in the machine room location. Most traction elevators today have regenerative drive. I would say that's pretty common today, that every elevator manufacturer offers that kind of as their standard offering. Hoist ropes or belts, depending on, again, which elevator manufacturer you select. They may either use the ropes or belts. Every elevator is a cab. That's what you guys get in and ride, and that's what you get to design with your custom finishes. They all have a counterweight system. That's what moves the elevator up and down. And then safety, governor, and compensation chainways are all other mechanisms of a traction elevator. If you guys have any questions, too, throughout, please feel free to interrupt me. A little bit about regenerative drive. So this is basically when elevators have this feature, it's kind of putting back system or use energy back into the elevator.
Yeah, traditionally, before regenerative drives or regen was introduced, all the excess energy, instead of it being stored, it was all dissipated through the braking resistors. So it was basically just adding additional heat to the braking resistors inside the hoistway, specifically on machine room list, or in the overhead machine room on an overhead traction machine application.
Yep. So it's a good feature to have if you are planning for this in your building system. So different hoisting machine configurations. What we're looking at here in the first picture is your overhead machine room. So that's going to be your traditional traction elevator system, where you have your penthouse room with the machine sitting on top, whether it be sitting on a slab or machine beam. Your adjacent and basement machine room, those are still used today, probably not as much as a traditional or machine room list, but if you are limited with space, you may want to look at, and you need to use a larger machine that would fit in a hoistway, you may need to go with the option of an adjacent machine room or a basement machine room. If you guys do any renovations in older existing buildings, you may still see some of these in the buildings that you guys are renovating, which we could always either replace with the machine room option or kind of go back in with the same style.
Yeah, and some of the nomenclature is almost intertwined between adjacent and basement. So if you call somebody in the office and say, hey, I'm really limited on my overhead, I want to do traditional overhead traction, but I can't. Can we, maybe move the machine to a lower level? Internally, we'd probably still call that a basement set machine, even though it's not actually on the basement. It could be like on the fourth or fifth floor.
Exactly. And lastly, the machine room list. Again, that's going to be your most used, most often today that we see in this market is the traction machine room style, eliminating the need for the traditional penthouse room, putting the machine in the hoistway. A little less expensive than your traditional traction elevator. So a little fun fact, elevator music was introduced in the 1920s to calm fearful passengers riding elevators for the first time. So today we really don't even, maybe some elevators have music in them, but now we're looking at TV screens in there, you got advertisements, so it's kind of another way to, I guess.
Got a cell phone.
Cell phone you're looking at, so no one's really paying attention much more. And back then, obviously, elevators were a little bit more new to everyone, so probably wanted to have something nice in there for your passengers. So what do we want to consider when we're designing mid-rise buildings? So these are some of the things that you guys need to think about when you're designing a mid-rise building. So again, these are also some items that we may ask of you if you're needing some help trying to decide your capacities or your number of elevators or the speed for the elevators in your building. I'm sure you've all worked with consultants before, probably even reached out to some elevator companies asking for some help on this type of information. If you're not really sure, can I use 3 elevators or do I need 4? Some of this information is very helpful for us or your consultants so we can determine the most efficient way to get people throughout your building. We'll kind of go through some of these on that page. So types of dispatching, there's 2 different types. This building here that you guys work in, you have your ECA type, which is shorter passenger wait time, longer passenger ride time. So it's a conventional dispatching system where you go up to the haul station, press up or down, and the elevator is going to, first one that's closest is going to come down and catch it. So you can see there, morning rush hour traffic, there's a big group of people, somebody hits the call button, one elevator comes down, everyone gets in, but not everyone's probably going to the same floor, right? Maybe they're all stopping on each floor, so you do have a little bit of a longer ride time. Now with ETD, estimated time to destination, that is called destination dispatch. You may have a little bit longer wait time, but your shorter ride time in the car is what this does. So have you guys, I'm sure you've seen destination dispatch, you probably even specified it in some of your projects, but this is kind of going to be the future of elevators. I mean, if you're thinking about it, everyone's phone here is touch screen. No one really even has buttons on, I mean, laptops, I guess, but phones are touch screens. People are going to want to have touch screens in their elevators. They like it in the hall just because of how it looks now, but it also will increase your efficiency in your building. So you have that same rush of people coming in the morning. You can either type in the kiosk on the touch screen there where you're going. Then based upon that information, the control system is going to select the elevator for you to get you to your destination. So it's going to kind of dissipate the people into different elevators, getting them to their destination as quickly as possible. Elevator security system. So this is another great feature to use with destination dispatch. However, you don't have to have elevator security systems with destination dispatch. You can use it with conventional systems as well. The most common one we see is pretty much, again, in most every specification that we come across is the card reader provision, whether that be in the car or in the hall. This one here is basically showing it being used with destination dispatch. So again, if you have a building with different tenants on every floor, and you want to use the card reader provision, and they can swipe their card with the kiosk, that's going to have all of their information. Say Carly works on floor 10. It's going to call the elevator and send me up to the 10th floor. I won't even have to do anything. I can just swipe my card. So it's kind of a neat feature to really kind of keep the security level in your building pretty contained with having personal information on your card, just getting you to the floor you work on and not having interfloor traffic. Why do you need to perform a traffic study? So again, this is kind of what I alluded to earlier about if you're not sure about how many elevators you need in your building or what capacities, can I use 3,500 pounds or should I bump it up to 4,000 pounds? Even do I need to use center opening doors? Simple things like that. This information is available by all of your elevator manufacturers, I believe. We all do this for free. So if you don't want to have to reach out to a consultant, you can reach out to the elevator companies and we can run a traffic analysis for you. There's simple mechanisms that we have, or we also have, as you can see in the picture, pretty detailed systems that will print out kind of very nice like spreadsheet of the different traffic times in your day. We can ask for that information, so we really can lay it out for you that you can provide to the owner and kind of sell them on if they're fighting you against, I don't want to pay for another elevator, but maybe that's the best option for them. So it's a kind of nice tool to have. Yes?
Quick question.
Yes.
What's the minimum requirement in order to develop the traffic study or education?
The minimum requirement.
Yeah.
So
Number of units,
Oh,
number of
units.
floors.
I mean, it was
Really
basically whatever information you could provide to
Yeah.
us as far as your number of stops, your floor-to-floor heights, your square footage per floor, because that would be beneficial as
Yeah.
well.
Yeah.
Because once we start getting into the nuts and bolts of the traffic analysis,
Mhm.
like on two-button technology like you have here, you're basically basing your performance on the interval, and that's the time between your elevator departures, so when it takes off. So usually an office building for excellent performance category, you're probably less than 20 seconds. Whereas you get into some housing conditions, apartment buildings, different things like that, you can have a longer lead time and fewer elevators. So you're probably, waiting upwards of a minute, so to speak. Whereas with destination controls, when you do those calculations, it's, as Carly was pointing out, it's basically, you're going to have a longer wait time, which is the opposite of the 2-button methodology, but your overall time to get there is actually shorter. Your time in the car, because it's going to group. It's a communistic way to elevator a building is what I refer to it as. So it's going to group like-minded riders and put them on that particular elevator, and then only serve, say, floors 7, 11, and 15. And that's all the stops it's going to make, and then it's going to return back. So it's whatever information you can provide us, kind of circle back, I guess, but whatever you can provide us as far as number of stops, overall square footage of your building, floor-to-floor height, we can kind of take it from there and run. I mean, we do have some kind of rules of thumb on like small 3-, 4-story stick and brick hotels. You're probably 2 passenger elevators, maybe one with a front and rear for service, laundry car, certain things. Once you get over, and then also if you can tell us what type of client or tenant's going to be in the building. If it's going to be a call center where you're going to jam 2,000 people per floor, then we would need to know that, because you're going to be way under elevator if you just go with, say, your average 90 square feet per person typical, whereas the call center, you're probably shrinking that down to half of that. So.
Yeah. So elevator location and grouping, more than one elevator, we always are going to recommend that. Every elevator may break down at some point or just needs to be routinely serviced. So you would like to have a backup elevator for that reason.
It's really big, like if you're designing nursing homes or assisted living facilities.
Yeah.
I have firsthand experience where we were literally, like 20 years ago, installing an additional elevator onto the side of a building to add a rear opening. So we had to take the one elevator out of service. Well, a person died on the 3rd floor. Rigor mortis had set in. They had to wheel him down the steps, and it was bad. So
not good. And even we've seen here in this area where some smaller hotels, like a 3- or 4-story hotel, they've put one elevator in, and we've told them, hey, that's really not a good idea in a hotel, but that was what they had budgeted for, and that's all they wanted. And here we are when the elevator gets serviced or it breaks down, and they're calling, and what are we going to do? Our hotel's full. Well, we should have one more elevator in there. So some things to think about. If you have a freight elevator, you might be able to have that somewhere else in your building, not grouped together. We typically like to group elevators together if you are going to have more than one. Just makes it, again, more convenient, more efficient for people to get in and out of your building as quickly as possible. So some of the space that's required, we all know that you guys, every inch matters, you guys. So thinking about kind of where your elevators are placed in your building, typically we see those in the core of your building. That doesn't mean that always has to be the case, but you see them, kind of coming in through the lobby, and then you have your typical core of your elevators. And you may have some others that are kind of back of house, maybe used just for employees only, or for the service elevator. But we also see the stairs typically behind the elevator door. So here we're getting into kind of the different dimensional aspects of elevators. So again, this is another important thing for you guys. This is probably the biggest issue that we run into with when we're looking at plans and specifications. You guys probably feel the pain as much as we do, that every elevator company varies in terms of their elevator dimensions. So it's hard for you guys to say you pick Otis as your basis of design. They have their dimensions. It's getting bid by all elevator companies out there. We all have different dimensions, so now we have to clarify that we don't fit or we need less or more. The best thing that we've been recommending is trying to say you're going to, this is probably a 4,500 pound or 5,000 pound capacity elevator in this picture here. Try to find the largest the hoistway dimensions out of every manufacturer and base it off of that. Even if you are kind of basing it off of one manufacturer, doesn't mean that manufacturer is going to get awarded the job. It all comes down to if it's being competitively bid. So it's a tough spot for you guys, and probably the owner too, if they do want a basis of design, but it's just come down to then it's on you guys to figure out how to redesign something and make it bigger than you're already planning for.
If you have a consultant like Lurch Bates or somebody, they're going to do the same thing. They're going to
Yeah.
take the largest hoistway and give you guys the BT drawings on that. And usually it's easier to shrink than it is to make everything grow within the hoistway. But yeah, knee-high, everybody used to have the same hydraulic and traction hoistway sizes. And then with the advent of machinery technology for hydraulic elevators and traction, everybody's hoistway sizes are kind of all over the place. So it's good to do. And Carly and myself, we would steer you in the right direction on being able to actually get you the plan for the kind of worst case scenario.
Yeah, exactly.
Pigeonhole you and to a certain subcontractor or anything like that.
Yeah. And, once you get into the front and rear elevators, front and rear opening, that's even a whole other story because everyone varies on that one and they all have to be pretty much spot on with those dimensions because your doors need to line up. So, again, if you design it a little bigger, it's easier to come in and bring it in. So overhead too, this is also going to vary on product type. So there's a couple different machine room-less elevators that are out in the market, whether it be self-supported or building supported. So both of those may have different overhead requirements for your clear overhead. So you need to just, I guess, check with your manufacturer on which product they're providing and kind of what clear overhead height requirements are needed. And when we talk about clear overhead, we're talking about the top of your finished floor, and that's to the underside of your first obstruction, which typically would be a hoist beam for a machine room-less elevator. However, if you have a building-supported machine room-less traction elevator, that could be even your machine or a machine beam. So this need to see what product you're using on that. Your pit depth, minimum pit depth for machine room-less traction elevators is 5 feet. That increases with your speed. Also, as your overhead will increase with speed as well. And if you guys want taller cab height, so say for example, a standard cab height is 8 feet, and you want to increase that to 9 feet, you're going to increase your clear overhead by a foot as well. So keep that in mind when you're designing. Machine room size. So here we're looking at a very nice, very clean, probably just freshly installed machine room. And this is for a traditional overhead machine room. So you can see there, your machines are actually in the room with your controllers. So this is just kind of outlining what it would look like. You have your adequate lighting that's required. You have to have your self-closing doors. Keep it nice and clean. All your disconnects in there. That's great. In the controllers. And then machine room with elevators, they can either have control rooms, control closets, or it's not shown on the slide, but they can also go into a front wall of your entrance jam, which has to be at your top landing. One of the things that we want to mention about having a control room or control closet is the distance. How far can that be away from the hoistway? So we like to say the maximum wiring distance is 150 feet away from your hoistway. And we're talking about the wiring from your machine to the controller. So whether that has to be vertically and horizontally added.
As the worm crawls, not as the crow flies.
That's correct.
And then if you design any projects in California, they now finally allow machine room elevators. But the control space, you can't do a closet or jam mounted. It's got to be a full body entry controller room. So if you guys are working on any projects in California, and there's some jurisdictions too that they're okay with either the closet or the room, but California requires a full body entry actual room, not a closet anymore.
Yeah, and if you guys do go kind of with the controller in the jam and the front wall route that way, check with your manufacturer on what their minimum front wall thickness needs to be. Typically, that's going to be a little bit bigger than your typical floors. For example, it might need to be a minimum of 8.5 inches. So that may vary. Maybe your other floors are only like 6 1/4 or something like that. So just keep that in mind when you're designing that, and it has to be at the top front wall entrance jam. And I believe that's probably the same for every manufacturer, but again, you might want to just check if they can move it somewhere else. And then building support. So this is another big one that sometimes can get missed. If you have a building supported machine room traction elevator, you may need some additional steel supports at the top of your hoistway or some pockets for your machine beams to sit in. Otherwise, if it's a self-supported, you will probably need a hoist beam. Some manufacturers may provide that, others do not. So that's one piece of steel you might want to show in your drawings. Some others are some intermediate supports, typically about 12'4" is kind of your span before you need some intermediate supports in between floors. And you all know if you have more than one elevator, you need to have divider beams in between.
And usually too, a lot of time it's missed is on the front opening or on your hoistway opening size on your entrances. Usually if you have anything over like a 10-foot or 12-foot span, same with the rail span, your entrances go all the way up. There's going to need to be some lateral bracing on the front wall as well to tie back those frames too as well. Yeah. And counterweight screening as well is always missed.
That is true. That's a
So if you have two elevators that are traction and your counterweights are either right next to each other, you got 3 cars or whatever, and you got 2 of them right next to each other, counterweights are next to each other, you have to guard it the entire length from the pit all the way to the top of the hoistway. Yeah. So it's an actual code requirement. It's got to be able to reject the ball 1 inch in diameter, 200 pounds of deflection of force onto it. So that gets missed every single time as well. So it's kind of a good note to kind of even put it in your architectural details.
Yeah,
still show out your entrance detail and pit ladder detail.
Yeah. So another fun fact, every elevator is supported by muscle fill cables, each being able to handle the entire load of the elevator. So due to the laws of physics, elevators were only able to go about 2,000 feet. However, there is a new ropeless elevator that's being designed. Has anyone heard about this or seen anything about it? You have? Yes, correct. It can go vertical and horizontally. So it's kind of like a Wonkavator with no rope. So kind of cool. And then the last topic is for fire service access elevators. So this is if you have buildings that are taller than 120 feet. If it's occupied floor space is taller than 120 feet, you'll have to, per code, have a fire service access elevator. Yeah. 2. So next slide is kind of going to tell you what requirements you need in terms of the sizing of your elevator. So per IBC code, a 3,500-pound side opening door meets the stretcher IBC code. So you can have, that's the smallest for fire service access you can have. Typically, you're going to see a service car, whether it be 4,500 pounds or 5,000 pounds, be designated as your fire service access elevator to be able to get your stretcher in and out.
So if you have like 3 or 4 car bank with center opening doors, and you don't want to make one of them a side slide, make it like a 4,000-pound car with a center opening door, and that's kind of your workaround. Even though it's going to be a 6-inch wider door, it still gives the same center opening look throughout your lobby. So you can have that with your, if you have a dedicated service car for your building for back of house. So those 2 cars would, they would meet the intent of the fire service access elevators.
Yep, and then they also have to have a dedicated lobby. So typically, like Steve was pointing out, if you did have a 3-car group and you wanted one of those cars to be a fire service access elevator, maybe that elevator would open on the rear side, the entire, all the floors in the building, while the other one is only going to serve the same as the other 2. So that behind the rear side would be your fire service access lobby. So it's going to have to be dedicated to itself. It could not be in the front side. Also, this makes sense, right? And the elevators have to run off emergency power, so you have to make sure your generator is sized accordingly to operate on emergency power for both of those elevators.
We can't have sprinklers in the hoistway or machine rooms as well for these, or shunt trips. And any type of sprinkler head that's outside the hoistway lobbies that Carly was talking about, if they're activated and water goes off, you got to be able to slope the entrance so the water does not come into the hoistways as well. Part of the new IBC requirements.
And that wraps it up. Does anyone have any other questions for us or any projects you're working on that you might need some help with?
For the touchscreen elevators,
Yeah.
is there a backup control system if the touchscreen doesn't work?
Yeah, there is. So we do have, typically, there will be, well, there has to be behind the actual COP panel, there is a lockable little door that opens with actual push buttons in it. But normally, if that's the case, say your touchscreen in the wall just like goes down, a lot of the times there will be two out there, but if you only have one, you can still operate it by using what's in the car. And then sometimes we'll have extra kiosks. A lot of the times the owner would request an extra one to be stored kind of like stock. Yeah, attic stuff for that reason. Yeah.
Also with the touchscreen things, is there a conflict with ADA and accessibility of I can't see it or I can't?
Right.
There's actually
Yeah.
a handicap
Yeah.
insignia symbol on it so that they can push it. And then it also has to give them actual directions
Right.
as well because the elevators with conventional, they're usually A through Z is how they're identified. So A, B, C, or D. So you go up and you're handicapped and you push the handicap button, and it's actually going to pull a particular elevator out of the group to make for more space for the handicapped individual. And it's also going to give specific directions. Walk 30 feet, turn to the left, go 5 feet, elevator A is there on your left. So they actually have to give specific instructions audibly and have the actual
The braille
handicap
and- yeah.
button braille as well.
On the touchscreen. Yep.
It's a handicap, is it voice activated or something? How do they specify what foot it is?
Well, yeah, it'll, it's voice activated, right? Yeah.
I'd have to check on that, but I know a lot of times sometimes they hit the button and they can say, or if they're able-bodied, where if they are blind,
Yeah.
and they can or have use of their extremities or hands that they can actually put in the form that they're going to. Or I'd have to double check on the voice recognition
Yeah,
to
I
see
think
if
it
that actually does that, but I would assume that's part of it.
Yeah. Yep.
I know when they first came out, the Department of Justice with ADA kind of pulled the emergency brake on them. It was like, hey, hold on, what are you guys trying to do here? And California kind of led the charge of this whole thing with the touchpads, and they've actually okayed them like 4 or 5 years ago. And the destination control, I mean, this thing's been around for like 30 years. It's actually finally gaining steam and momentum, and the technology has made it more cost effective nowadays. So that's kind of one of the driving factors behind it. And the buy-in from AHJs and everybody, Department of Justice, everybody has given their blessing and their backing on the touch screens. And some of them don't actually have to be touch screens. Some of them are actually just like big, like buttons, just little kiosks with buttons on it, like you'd have at your ATM. So it just depends. The touch screens are kind of the more flashier kind of thing, but there are some scaled down versions of just regular kind of little buttons, like the old telephone bank.
When we're arranging the floor plans, like our top floor, we have the control room. Are there jurisdictions that allow us to put the control room features inside of another room, like the electrical or telecommunications closet, or does it always need to be separate?
Usually it needs to have its own dedicated space. If it is like within its own electrical room or another electrical space, sometimes they'll make you put like a cage link fence up to have a separation barrier. But I know with some of the machine roomless units that are true machine roomless, where the controller's in the jam and the elevator companies are providing the disconnect, but you still need to have the power from the hoistway back to the control space or to where the main line switch is. You're gonna have to have a disconnect there, so that's fine. But as far as trying to group it all with like an IT controller space, with the actual elevator, most of the time, probably 99.9%, you're gonna need your own dedicated space. And a lot of it's more or less liability issues. because this is high voltage equipment. They don't want people, a lot of it's driven by the IUET, the union guys. They don't want other trades messing with their equipment. And, you know, if something happens to a person too, a mechanic, they go in, we always ask for the door to swing out. So they get electrocuted, they fall down, the door swings in, well, then you're banging the guy when he's laying down on the floor unconscious. So if you can have the door swing out, that'd be fantastic. See that all the time.
See that?
Yeah.
Some of those guys, it'd be okay if they hit them out.
Anything else, you guys? If not right now, and you think of something later, I left some of my cards for you guys. Feel free to reach out anytime. Appreciate you guys taking the time out today to listen to
Thank you.
elevator education. Thank you. Yeah, you're welcome.